Okay, financial models. Let's start with the easiest ones, and that's just simple interest. I equals principal, rate, and time. Uh, simple interest. And simple interest just means it's a lump interest. It's not like you get so much of your investment back this month, so much next month. It's not like a normal savings account. It's a lump sum interest type situation. Simple interest. Simple because that's a very simple formula. Interest P is for principal, not like Mr. Martin principal, but principal investment. R is the rate. So interest rate like 3%. Now, normally, that's if you're taking out a home loan, about 4%. It's normal right now. And then T is going to be time. And anytime we talk about time in these formulas, it's going to be in years. Okay. Time is in years. Okay. So this is simple interest. It'd just be like you get a one-time interest back on an investment. You're not continually putting money into it. It's just you put it there, leave it for a certain amount of time, and how much interest do you get back? So let's look at a couple examples of that real quick. What if we're investing $1,500 at 2.5% simple interest? And when you're reading these problems, you want to make sure you pay attention to that. Simple interest. We'll talk about something in a second. Compound interest, and then continuous interest. Three different formulas to go with there. Simple interest for 4 years. Let's say you guys graduating this year, you get $1,500 in graduation gifts, and you decide, I'm not going to spend this. I'm going to put this back, and for 4 years while I'm in college, and then I'll have something, back after that. So, how much do you gain? How much interest is gained? All right. So simple interest, it told us that. So this is the formula we're using, and we're trying to find interest on this one. It's the most simple example that we can do with this. So the principal investment is $1,500. Our rate is 2.5%. We're going to convert that into a decimal. So 2.5% would be 0.025. And then our time is 4 years. And all we're doing is trying to find out how much interest we're getting off that investment. It's a simple interest type thing. So let's multiply that out. 1,500 times 0.025 times 4. $150 back for doing nothing. That's our return on our investment there. 1,500 at 2.5%. Now, if you can find us a savings account that gets 2.5% at any bank around here, let me know. I want to put my money there because it's actually like half of 1% is what most banks are giving in a regular savings account right now. But you can get higher rates if you're willing to leave your money there longer. A normal savings account, like they expect you to move money in and out of that account. But if you go to like a mutual fund or an annuity, which is like a savings account, but you don't have access to your money until it's matured. So like, there's cash deposit CDs. They have time links. You can have a 1 year, a 2 year, 4 years, 7 years, different time links. The interest rate goes up the longer you're willing to leave your money there because they use your money while it's there. Just so you know that they invest it in other places. But they guarantee you a certain amount. So that that they're making more of that. So, all right. So let's look at, what if I need to, put some money back and I want it to earn a certain amount. So let's make it an equation so it's a little bit more our level here. So how much should I invest for 6 years? Say I'm going to go to grad school too. And I find an annuity or something that's a 6 year, or maybe it's a CD, it's a 6 year CD that's going to pay me, guarantee me 3%. And I'm leaving it there for 6 years and not putting any extra in there. I'm just putting some amount in there for 6 years at 3% interest. And I've decided I need to earn, I want to make $400 on this. I think that's a fair amount. So to earn $400. Again, this is simple interest. There'd be a few more context things in the word problem if you were dealing with that. It would probably say simple interest. So again, simple interest formula, and we're plugging in the stuff when we know. What do we not know in this problem? Principal amount. So we know that the interest we're earning, or we want to earn, is $400. The principal investment is what we don't know. So we just have an equation to work here. 0.18 P to the 400 divide 400 divided by 0.18. Yeah, lots of twos there. So let's round to the nearest cent. So 2,222 and 22 cents. $2,222 and 22 cents. We invest that amount, we're going to get close to $400 after 6 years, and that's doing nothing. Simple interest, though. Simple interest, most basic thing. All right, well, let's go to what's more normal, which is compound interest. Compound interest is the way a normal savings account is done. Reverse compound interest is how, like, credit cards and things like that determine how much your payment is and things like that. If you don't pay it off when you get the bill in, so it's a reverse out of this. But we're talking about getting money back. We don't want to talk about money going out because we want money back. Okay, here's the formula. A is the amount the account is worth. Use A for account. There's what they use there. P is still principal investment. And then the formula is 1 plus R over N, parentheses, to the NT. Okay. R is still our rate. Our N is how many times the interest compounds. Okay.
Good morning, AJ. Please rise for the pledge of allegiance.
Let's do our pledge.
I pledge allegiance to the flag.
All right, so N is how often the interest compounds, and we'll talk about that in a second, like what's common for that. T is, again, years of time. Okay. T is still principal. A is account worth. All right, so all of those things. Now, N, how many times it compounds? There's different ways of doing that. You could compound interest daily. You could compound interest monthly, quarterly, biannually, or semi-annually. Another way of saying that. So it's different according to what bank you're at. Most banks locally, their regular savings accounts are quarterly. So that means it compounds how many times a year? 4 times a year. Okay. So every third, every multiple of 3 months. you get your interest put into your account. And that's how they do that. So, but that changes according to what kind of account you have and where you have that at. You can do some of the national banks that you can do accounts with. They compound it differently, different places, and sometimes some of them have different tiers about if you keep the minimum balance over $1,000, they compound your interest differently. So there's different rules that they follow there, but it's this formula that they're using to get that. So let's look at that same problem that we did for example A, where we're investing $1,500. It was 2.5% interest, so that's really high interest rate for a savings account right now. Compounded, and then we'll do quarterly. For 4 years again. So it's the same problem. We're just compounding the interest quarterly this time instead of simple interest. Okay. And if you remember example A, we got $150 if it's simple interest is what we earned out of that. So put that into the formula. Principal investments 1,500, 1 plus 0.025 over 4 to the 4 times 4. So that's principal investment. This 1 is always going to be a 1. Your rate divided by how many times you're compounding. Okay, so 0.025 divided by 4. And then this is number of times compounded times the years. 4 times 4. So both 4 is the compounded quarterly, and the other 4 is the how many years we're dealing with there. And then we're just going to work that out on this one. So 1,500 parentheses 1 plus 0.025 over 4 close parentheses, and I'm just going to go ahead and 4 times 4 is 16. Just put a 16. The account worth is, you can't see that, $1,657.24. Is that what y'all got? And you multiply it, work that up. $1,600.57 or $1,657.24. Little bit more money than what we made with simple interest. Not much, $7.24 more, but that's still more out of that with compounding quarterly instead of simple interest. So you get a little bit more on that investment there. Okay, so let's look at one that's maybe not as nice, in the fact that we've got to solve the equation a little bit. So we'll start with an easy one. How much should I invest to have an account worth $6,000? So let's just say, I'm thinking, I'm going to college soon. I'm going to put some money back, and I want it to be worth a certain amount because when I get out of college, I want to have a nice little piece of money there that I can take and furnish my apartment in whatever city I decide to live in and use my degree. So that's what I want here. I want $6,000. Gives me enough to move and be settled and find that first job maybe within the first month, hopefully. After, let's say I got my 4-year degree, and then 2 more years got my graduate degree. So after 6 years. And because I was just gonna, I'm gonna put some money back and I'm just gonna leave it there. I'm gonna be at college. I'm not gonna be making any money while I'm there. I'm just gonna leave this money there. So I've been able to find this annuity that gives me 3.25% interest, compounded monthly. Okay. So how much should I invest there? So I'm going to set up my equation. My account worth is $6,000. That's what I want at the end. But I don't know how much I'm investing. So P is what's missing. And everything else kind of fills in here. Compounded monthly. So N is going to be 12 in this case. Not 76 years. So we're going to try to solve that for principal. So I'm going to get that number because all of this is kind of ugly, but it's just a number. So I'm just going to work that number out. So 1, oops, I'm going to use parentheses. 1 plus 0.0325 divided by 12 raised to the 12 times 6 power would be 12 times 6 is 72. Don't round that at all, okay, when you do your calculations. So 1.214. So I'm just going to put 14 ... And then we're going to divide so get our principal investment. So don't round that at all. 6,000 divided by that number. I've got to put almost $5,000 back. $4,938.31. I'm going to round to the nearest cent today. That's $38 and 31 cents. So hopefully, maybe I got some really good graduation gifts. That'd be a lot. I don't think I know anybody that got that much, but maybe you did. But and that would earn you. If you put this amount, you're earning almost $1,100 in 6 years doing nothing. And that gives you that investment. So there's a nice example of that. Let's look at what if we need to know how long we need to leave something there. So the other situation that can happen here is how long must we leave $1,500? So that's a more realistic number in an account. Draws 1.5% quarterly. All right, so here we're looking for how long do we leave the money there to get $2,500 is what our account is worth at the end. So really to earn $1,000, how long do we leave it there? So setting up your problem, $2,500 principal, we do know this time, 1 plus interest rate 0.015. Quarterly is going to be 4 times a year, but we don't know the time. So here, this is why this is in this chapter with all the logs and stuff. We have a situation where the variable's in the exponent, which is more like what we've been doing this chapter, okay? So work your way through that and get the variable by itself. So you want to get rid of the 1,500. So divide by it. 1 plus 0.015 over 4, the 4t. That's just a number. I'm not getting the decimal for that right now. just because I don't want to round it at all at any point. 2,500 divided by 1,500. It's something over 3, 5 over 3. I'm going to leave it as a fraction because that's a repeating decimal. So I'm trying to avoid that a little bit. Okay, and then how do I get that variable out of the exponent? Say it again. What's legal to let me do that? That's right. I need to move it to the front, but how? That's a good idea. I'll take the natural log of each side, and that allows me to have natural log of 5 over 3 equals 4t times the natural log of this stuff, 1 plus 0.015 over 4. That power rule for log, power property for logs brings that down to the front. And now, I've got natural log of a number. This is natural log of a number. I've just got to get the t by itself. So what do I divide by to get t by itself? Not just 4, but 4 natural log of this stuff. It's like solving a logarithmic equation or an exponential equation is what you're doing here. And that's going to get me t, and divide that out. So calculator, I'm going to do natural log of 5/3 divided by, and then parentheses, 4 times the natural log 1 plus 0.015 over 4. Close parentheses twice. And enter 34, and let's go 2 decimal places, 34.12 years. So we got to leave it there for 30, almost, 34, a little over a month, couple of months, almost not quite 2 months, but to earn $1,000 at 1.5% interest. This is why 401ks and things exist, because you can invest in stock markets and money market accounts, and you gain money faster than regular savings accounts. So just so you know. All right, let's look at the last thing here, and that's continuous interest. Continuous interest is like the compound interest, except for it's continuously compounding interest. It's not monthly, quarterly, or daily. It's every second of every day. And when you crunch all those numbers and what you do with that compound interest formula and you work it out, what happens is your account worth is principal times e to the RT is what it ends up being. To me, it's a simpler formula. You got e as the base, so natural log is going to be involved here at some point to solve this. So really, really, simple idea. Okay, so we'll just jump to the what if I want to double my investment? So let's look at that. Simple if double the investment at, let's say we have an account that's 5% continuously. If I'm going to double my investment, but they don't tell me how much my investment is, what do I do? It's continuously, so I know it's the PERT formula. That's why I always remember that. PERT. I don't know if they even still make PERT shampoo. There used to be a shampoo, PERT brand. PERT. PERT. So the PERT formula is what I'm using because it's continuous. Now, if they said double my investment, well, how much did I invest at the beginning? What's the easiest number to double? What if I invest $1? That's the easiest thing I can do. Because then, what's my account worth if I double it? $2. Make it easy on yourself. All right, but I know my rate is 5%, so 0.05 t. I'm trying to find how long I got to leave it there to double it. Okay. If they told me my principal investment was $200, then I would have 200 here and 400 over there. They don't tell me investment. Make it easy. Use easy numbers, 1 and 2. Okay, and then get rid of the 1. That's the easy part. We have 2 equals e to the 0.05 t. Well, that doesn't work. There we got a variable in the exponent. So what do I have to do? Get rid of it. Take log of that. So what log am I using? Natural log of each side. And left side's natural log of 2. What happens on the right-hand side? The natural log and the e cancel out, so I got 0.05 t. Like the continuous interest are easier, in my opinion. Divide by 0.05. Natural log of 2, close parentheses, divided by 0.05. How long does it take me to double my investment? 13.86 years. If it said triple my investment, what changes up here? Yeah, if it said quadruple, 4, that sort of thing. Okay, so even on the continuous interest, if where it's compounded quarterly or whatever, you're still going to use that 1 to whatever ratio. If it double the investment, compounded quarterly at 6%, you'd still use that same idea there. It's a very, very simple idea. All right, there's one other little test that and it's a quick thing, and it's to compare a continuous interest and a compound interest situation. If you want to compare them, what you have to look at is what's called the effective rate of interest. Effective rate of interest. For compound, they use R base E is the effective rate of interest. That's their notation for that. Effective rate of interest is the parentheses part of the compound interest formula. For the continuous, it's E to the R minus 1. The higher one is better. Okay? If you're comparing the effective rates of interest, these little formulas are going to be handy. Okay, so and usually if you're comparing effective rate of interest, all you're doing is doing these formulas and picking which one has the highest interest rate. That's the bet. That would be better for you as an investor. Okay. Effective rate of interest. As far as formulas go on quiz tomorrow, I'll have them for you. The compound, all that stuff. Since I'm kind of shorting you on your time with this, so I'll have formulas for you for that and for the effective rate of interest and things for the quiz and the test on Wednesday. I'll give you those formulas for that. This is not something that's usually even on ACT, so I don't feel bad about giving formulas for that. All right, so page 472, 7 through 67. Good practice there. Looks like a lot of word problems, but it's just those interest problems. It's all it is. And pay attention to what it's asking. If it says compounded quarterly, daily, that's the compound interest formula. If it says the word continuously, that's the PERT formula. That's the difference. Simple interest. Simple interest is not going to be used at all, really, honestly. It is, you're not going to use that it won't be on the quiz tomorrow. I'll go ahead and tell you that. But if it says simple interest, that's the formula you use. So pay attention to what they're asking you to do there. All right. So